stages of cancer development. So these are areas where we felt things were not well done. All right, now that really concludes the portion of what I had to say on the studies from the NRC that were conducted as a result of that workshop a year ago. I was asked yesterday to add one additional thing that has nothing to do with the NRC, which was to look at the problem of defining temperature and thermal and athermal events. Now, the way I define temperature as a convenient way of describing a distribution in energy of particles, all right? And typically at thermal equilibrium, the number of particles at a higher energy is reduced by comparison to the number of particles at a lower energy. And since let's see, I gave my pointer away. I've got one here. So, for example, at energy level 3 here, and the reason this graph is so bad is I'm not very good on drawing on a computer. My students do that thing and they get it straightened out. When I had to do it last night, it took me forever. All right, so at this energy level, you clearly, at thermal equilibrium, have a smaller number of particles than you have at this level that you have at this level. And these things decay exponentially with the difference in energy. The temperature T is a convenient way of describing this N. Now, in lasers, we wind up inverting the population. So by pumping heavily here, if you have a fast relaxation here and a slow relaxation here, you can wind up, if you think of these as buckets of water, with all of the particles in the middle pocket. Since the probability for transition from one level to the other level are equal with the absorption probability, what you see is whether you see gain or loss depends on whether there are more particles in an upper level than there are in a lower level. In the laser, we get this, and we find it very convenient to define temperature so that it has a negative value, and that gives us a description of this. So positive and negative temperatures are useful. So if we're looking in terms, coming back to our discussion here, if we're looking at a description that involves a change in the distribution of the energies of a particle, or of an electron or an ion, or whatever, then we're going to wind up with changes in temperature. And I don't care whether you're talking about microdegrees, picodegrees, or tens of degrees. We're talking about something which, described this way, involves a change in temperature. Now, you can get things that don't involve changes in temperature. For example, you can change the polarization. If something pointed up or pointing down, it can have the same energy. The classic example of this is if you have drive a spike through a 2x4. If you step on it when it's on the point, you get a different reaction than if you step on the other side, right? It took essentially the same energy to get to each place. Okay, well, I hope that at least says how I look at temperature, and other people can have other ways. A second comment I would make is people talk about non-ionizing radiation. That bothers me. And the reason it bothers me, you're talking about a single quantum of energy, and the radio frequency does not have enough energy to ionize a typical particle. On the other hand, if I use RF to drive a plasma, where I've got lots of photons, I can generate ions all over the place with radio frequency energy. So again, I feel one needs to be careful about how you use these definitions. With that, I'll quit. Thank you very much.
Thank you very much. Before we open it up for questions, I just want to kind of summarize the information and integrate it in a way that I hope will be helpful as we think about public policy. There are so many different ways to influence public policy on this issue, and there are many different ways that public policy influences what happens on this issue. So I'm just going to say, for example, there are three kind of major ways that I can think of to think of this issue as a policy issue. One that we've heard a lot about, which is funding research and what research is being done. So a big focus has so far been getting more government money to do research, and that is happening in many different countries, including the United States. A second possible way to deal with these issues are public warnings, and Israel is a good example of that, and other countries as well, where they're not restricting, they're not banning, but they're making information available to the public to talk about what concerns might be, and whether that's done on the basis of a precautionary principle or on the basis of talking about what the data shows so far. It's still another good way that different countries have approached this issue. And the third, which kind of all goes together, are bans and restrictions and criteria and limitations. You can make restrictions on the kinds or levels of radiation allowed on certain devices. You can put bans in terms of, or restrictions or criteria on how products are used or who they're used by. These are the kinds of policies that are harder to get passed. You usually need a lot more evidence to do them. And they usually come, I would say, later after the research has been funded, after the warnings have been done. And I should also say that these public warnings can be in the form of required warnings on advertisements. For example, the FDA does require, when a drug has been advertised on TV, that certain warnings be included in the advertisement. Sometimes those warnings are extremely fast or in little tiny type, and they're not very effective, but it is one of the ways that you can get information out more widely, as well as having information on the FDA website or having a press conference where the national media pick up information. So, and then I just want to speak very briefly on the different ways that bias can influence these approaches. First of all, for research, obviously, what kind of research is done, how it's done, how it's interpreted. For example, if evidence is not clear, you can interpret it as saying there is no evidence of harm, or you can interpret it as saying we don't know yet, but we're concerned. And so those are two very different ways of interpreting sometimes the exact same information. And another way that research can be biased or can bias public policy is when certain individuals or entities flood the research literature with studies purporting to show that something is safe, or interpreting data, sometimes from very well-conducted studies, but interpreting it to say that something is safe or not safe. So it can go in either direction, but when people have a particular bias and point of view, if they have the wherewithal to flood the research literature, and we've seen that on many different issues, then it's very hard to do the kind of meta-analysis or research review that the American Cancer Society talked about, because you might want to know not just how many studies show a problem and how many studies show not a problem, but who funded the studies and how well conducted are the studies and how are they interpreted. And then a third issue here is the extent to which public policy is influenced by a precautionary approach or really strongly tied to data. And in the United States, we haven't been particularly interested in a precautionary approach on most issues, and there's been a lot of reluctance to take that kind of approach on many, many different issues. And while those kind of approaches have been taken by European countries and the European Union on some other issues that the United States has not. However, there have been a couple of developments in the last couple of years in the United States. For example, in a recent law, there is a ban on phthalates, which are certain chemicals in children's toys, not because the evidence was clear that they were dangerous, but because it was felt that the benefits of such a ban outweighed the costs of such a ban. And so people argued about whether that really was a good idea or not, but definitely a precautionary approach was taken that was really quite unusual for the United States to do, because the usual thing is let's do more studies. And let's study this for as many years as necessary before we make any conclusions. And I think that's been a big push in the United States, and it's one of the things that has frustrated many advocates on many different issues. The sense that that the government would much rather study an issue to death than they would move on it. But as we've heard today, there's a lot of different opinions on that. How much data do you need before you either change public policy or take a precautionary approach to concerns?